Hi everyone. In the given problem of path sum, given the root of a binary tree and an integer target sum, return true if a tree has root to left path such that adding up all the values along the path equals target sum. So how to solve it? So basically, let's say we have a tree of 5, 4, 8, 13, another 4 and 1. And it's not a binary tree, it's just a normal tree that we have to traverse element by element. So here 7, 2. So as you know, right, if I'm going to traverse it up, there are few ways of traversing: pre-order, in order, and post order. So here, right, our target sum for this problem is 22. So I'm going to solve it using, let's say, pre-order. So first we are going to do the root. So we got the element value of 5. Then we are again on the 4 plus 11. So we are going to traverse like this. What is the current value? 20. Okay. Then we come here at the 7. So 20 plus 7, it is going to be 27. Once we're at the 27, we are going to check whether it's a leaf node because it's been written right from root to leaf. So from root to leaf, we are reaching till the 7th, and here the value is 27. 27 is not equal to 22. So what we are going to do, we are going to move up, and from here, from 11, we are going to go to the 2. So it would be like 20 plus 2, which is going to be 22. 22 is equal to our target sum. So it is correct. So right, we are going to return true in that case. So here you are able to see, right, you're just doing a pre-order traversal, traversing all the node values, and once we reach a leaf node, we are going to check the total current sum is equal to target sum or not. In case it's not target sum, we are going to return false, else we are just going to go back and going to check it out. So if I have to do it in an code format, right, so the value would be DFS. We are going to take the parameter of root, and let's say to calculate the sum, so sum in that case. Obviously, if it's not root, then our standard procedure, which is return false, then we are going to do sum plus equal to our current root value, so root dot val. Now the important stuff that we have to take care of, which is if, let's say we are at the 7th, right, so if root, or let's say if not root dot left and not root dot right exist, let me write it properly, root dot right exist, in that case we are going to check our current sum equal to our target sum. In that case we are going to return true. So that is the condition, and also right at last we have to also return. So we are going to do a DFS, so it would be return DFS of root dot left, and our current sum we are going to pass in, or So either of the means if you're able to find it in the left node or the right node, it doesn't matter. So either of them, right? If it's returning true, we are going to return true. So dfs root dot right and current sum. So that's pretty much the code, how you're going to traverse it up. And also one more thing that to remember, let's say our target sum is 0, right? And our root is null. So we are getting an empty tree. In that case, whether we should be returning true or false, we are going to return false because it has been clearly written, right? From root to leaf. Means we are going to calculate path from root to leaf. So even if it's 0, right? And our target sum is 0 and we are getting a root tree or a null tree, right? In that case also we have to return false because it's not root to leaf path. So we are only going to calculate the sum of root to leaf path. So that's something to be taken care of, and our pseudo-code that I have written is going to take care of it. Now let us jump to the Python solution. So the first thing that we're going to do, we are going to define our DFS function, and we're going to pass in root and our variable from where we're going to calculate or keep on adding the root values out here. So current sum. Now the first thing we're going to do, we're going to check if root value is null. So if not root, in that case we are going to return false, else our current sum plus equal to root dot val. And now we are also going to check if it's a leaf node. So if root dot left, so let me type in if not. So one case of checking right leaf node, it is not going to have a left child or right child, and not root dot right. In that case, if our cur sum is equal to our target sum, we are going to return true, else we are going to keep on iterating. So dfs of root dot left, and we are going to pass in the current sum, or dfs root dot right and our current sum. And at last we have to return dfs root, and initial value of our current sum is going to be 0. And if I run it up and all the spellings are correct, it should run properly. Let us check. Yes, all the public test cases passed. Let me submit it up. And if I look into the time complexity, it is going to be big O of n, which is a linear time solution, because here we are going to traverse all the elements one time, and the space complexity would be also same, which would be a linear time. Let me run it up again. So even it's showing beating 33.83%, but our code is pretty efficient and very standardized. So we are good to go. So that's all for this video. See you in the next one. Here it's showing 100%. So it's keep on changing. So that's all. Thank you for watching.